So we're going to take a look at the Inferential Statistics template, which can be rather intimidating the first time that you look at this template. So I think what's important to remember is that the first thing you should do is open your descriptive statistics submission, and you should copy in from that document your sample proportion and sample size. So you've already done this in that document. There's nothing for you to do here. Then for question 5 and 6, you also have in the descriptive statistics assignment done these pieces. So you found the sample mean, the standard deviation, and the sample size. So once these are in here, it's going to start calculating things, and you'll see these values start to change. And so as I look over here, I'm going to be able to fill this in and get it to change. So the other piece that's important is you have to copy all of the formulas from these cells here into the first part of the spreadsheet. So what I'm going to do is I'm going to highlight all of them. I'm going to hit copy, and then I'm going to go over here and I'm going to hit paste. Now you're going to notice that there's nothing here right now, and that's because I have to fill these values in. And once I fill these values in, then it's going to start populating things here. And so as I start to fill this information in, I'm going to start to get out of here what I have going into it. So let's just kind of take this same piece, let's populate the same values, and then you'll see that this calculates the same. So the big thing is you've got to make sure you have these values. If those values aren't there, the formulas are just going to show this. Now for the conclusion, the whole point of a confidence interval is to tell us that the mean is somewhere between the lower limit and the upper limit. So if I look at this example, you'll see that we say we're 95% confident, so we're like really sure that the true population proportion is between 0.293 and 0.547. Now you'll notice those two numbers do not match this information right here, and that's because we're trying to give you an example. So you would need to make these two numbers match what's here. Okay, so this is an example of what you would type in. The numbers 0.293 and 0.547 are not found on the page. Those are coming directly from the upper and lower limit. This is just an example of what you would say. And we're going to talk about this in the final submission. We wouldn't actually say population proportion. We would actually say what it is. So we're 95% confident that people spend between 5 and 7 hours on the internet a day. That's how we would actually say it, but this is more about just the procedure. And so again, the same thing happens here. You would want to copy the formulas, which are going to be located. I'm going to highlight them and click copy, and then I'm going to click paste. And once those are copied and pasted in, if I go to my descriptive document and I copy things and I paste them in the cells, you will see this automatically populates. So that's a big piece of this, is making sure that you're taking the information you already did and then bringing your formulas over. Now, this sometimes throws people off. So this is whatever your best guess is. So for question 1, you're going to look at what your estimate was. So if your estimate was that 50% of people are going to be a yes and 50 are going to be a no, then you could say that the probability would be greater than 50, or that it would be greater than or equal to 55, which is 0.55. The big thing is that your percentage or your value has to be in a decimal format if you're using a percent. In questions 5 and 6, maybe you said, okay, I'm studying how long people spend on the internet, and I estimated that people spend 17 hours a day on the internet. So in that case, your your null hypothesis would be that the mean is 17 because you think it's going to be exactly that number. And then the alternate is the exact opposite, that it is not equal to that value. Once you have this information here, in the case of an equal and not equal, this is always what you use right here. You'll see this test statistic is calculated from all of our previous calculations. So when you're looking at things, you're going to look at this test statistic and you're going to say, is this equal to 17? The answer is no, negative 73 is not equal to 17. So you're going to reject the null hypothesis because it's not equal. In this case, we get that it is 21.3 and we need it to be greater than 1.645. If it's greater than 1.645, you're going to reject the null hypothesis because this happy green box tells me that if I'm looking at greater than 1.645, then that means I'm going to reject it. The same thing happens. Let's look right here, this example. So I have an equal and not equals. So when I have an equal and not equals, that's going to be this scenario. So that would be this part of the green box. So this piece of information is coming from the green box. So if I'm looking at this line right here, I want to make this row a little better. So here I thought 60% are going to say something, which means that my alternate is not 60%. So it's very, very scientific here. We have it is or it isn't. And so if z is less than negative 1.96, or if it is greater than 1.96, then I would reject the null. So if I look at my value, 1.913, negative 1.913 is less than negative 1.96. So I'm going to then be able to say I don't reject it. And so this column is not filled in with the formulas when you copy the formulas over. This column is coming from if you're saying that it's going to be less than something, you use this value. If it's going to be greater than, you're going to use this value for the test statistic. And if it's two-tailed, you're going to check for both of these, and then that test statistic will inform what you put here. Now, if you reject the null hypothesis, that means you have sufficient evidence to show the population proportion is less than whatever the value you put here. And so, same thing, if I reject, there is sufficient evidence that it is going to be the value that I put here. So this is really simply copying the formulas over to the front tab, creating your hypothesis, and again, there's no right or wrong way to do the hypothesis, it's just what you think you're going to get as the answer for number 1, 2, 3, 4, and so on. And then it's just following the criteria in the green box. So make sure that you're looking at the green box as you continue to go through this. And that is how you do inferential statistics.